In the final section of this module, we're going to look at how to connect the insolation data that we now know how to access with PV output and energy, specifically the amount of energy that we could produce. As a refresher, in the last lesson, we looked at how to obtain insolation values, both using the NSRDB or a spreadsheet to get global horizontal insolation values. Once we have those values, we can use them to calculate annual insolation. We do that by taking the daily insolation and multiplying it by 365 days per year. To determine the photovoltaic energy, we have to consider that the electrical output is a factor of the insolation, the system size, which is how big the photovoltaic module is, and the overall system efficiency. The system size is typically given in power units of kilowatts, although an individual panel might just be rated in watts. The system efficiency can be determined empirically, although it's usually around 80 to 85%, which includes things like outside the panel itself, things like dust, soil on the photovoltaic panel, wiring mismatch, inverter inefficiency, and a few other items. Looking at units, we can multiply the system size, which is in kilowatts and defined by standard test conditions, 1,000 watts per square meter, by the full sun hours, which are the hours of sunlight at standard test conditions per year. Multiplying that by the system efficiency gives us the overall energy. In this example, we could take a system that's 8 kilowatts and multiply it by the insolation, in this case, a location that receives 4.8 full sun hours per day. Multiplying that by 365 days per year gives us 1,752 full sun hours. Multiply that by the efficiency of 85%, and we get the final value of 11,913.6 kilowatt hours of electricity. Going the other direction, we could calculate the size of the system based on a known energy need. So for example, using an electrical bill, we know the annual energy need, and we have to calculate how big a system is needed to produce that energy. In this example, we have an annual load or use of 7,000 kilowatt hours per year in New York City. The insolation value for New York City from the map is 1,642 full sun hours per year, and the system efficiency is again 85%. We need to produce 7,000 kilowatt hours of electricity, so mathematically we divide 7,000 kilowatt hours by the 85% system efficiency. We then divide that total again by 1,642 full sun hours. That tells us we would need a 5.01 kilowatt PV system to produce 7,000 kilowatt hours of energy in New York City. That system will always be a 5.1 kilowatt PV system because it represents power. But if that same size system is placed in a location with a greater insolation, it'll produce more energy over the year. Likewise, if that same system is put somewhere that has less insolation, less energy. So let's finally look at units. So I've gone back and forth saying full sun hours and kilowatt hours per square meter per day are the same. However, if you're a unit purist and want to understand a little bit more of these pieces, look at the supplementary module where I explain how the units work together to give us these values. In the end, you should now be able to use annual insolation values to calculate the potential electrical energy generated by a photovoltaic system at a location, as well as predict what size system you would need if you knew the electrical load requirements as well as the system efficiency. In the next module, we'll look at circuitry and wiring for photovoltaic systems.